Hey, everybody. So we're looking at our worksheet for all of 15.1 today. Just to give you an overview of this, the first page is going to be all about central angles, and then the second page is going to be all about inscribed angles. So part one and part two of 15.1. So let's just jump into it. Okay, it starts out really straightforward. The first section is just asking us to name whether the arc is a minor arc, major arc, or a semicircle. So I just want to take a look at one of these. If you guys take a look at number three, it's saying arc EAC. All right, so just remember that arc starts at E, goes through A over to C. So EAC, that's arc EAC. Just one thing I want to, I guess, remind you when you're looking for arcs or naming arcs, you never cut through the circle. All right, so just be careful of that. I'll sometimes see people go like through the circle and then around it to like follow an arc. No, you're always going around the circle. Okay, so after I highlight it, hopefully it becomes obvious. This is going from one end of a diameter to the other end. This is a semicircle. Okay, so there it is. Okay, and I'll let you find the rest of those. Just remember, if it's named with two letters, it's implied to be a minor arc. So you really don't even need to look for those. If it's two letters, it's minor. Okay, but double check between the others. Okay. All right. On the next section, it's asking you to find the actual measures of the arcs. A couple things it says segment PR and segment QS. So this and this are diameters. I don't know if it was necessary for them to say that. I can see their straight lines going through the center, but now we're certain. Okay, so take a look at number 9, asking for the measure of arc PQ. Okay, so that's an arc that goes from P to Q. By the way, I know it's a minor arc. I know it's the shortest distance from P to Q. Okay, by the way, if it was going this way from P to Q, there would have to be a letter in between, like for example, PTQ, something like that. Okay, so anyway, that's what they're asked. That's what we're asked to find. All right, here's my first thought. If I can find this central angle, then I will be able to get this arc. Remember, the central angle and its intercepted arcs have the same measure. All right, and maybe this is something you notice already. I have its vertical angle. All right, so if this is 42 degrees, I know this is 42, which means this is 42. Okay, and I recommend putting all of this information onto these circles because it's likely going to help you to know that these are all 42. Okay, so there is number 9. Okay, and then I'll let you kind of go through those. Again, look out for those diameters, cutting the circles into semicircles. That's a big part of a lot of these problems. All right, let's keep moving down the line. Numbers 19 and 20 are kind of just out of left field, kind of weird problems. Here's what it's saying. PQ has a measurement of 90 degrees, arc PQ. So they're telling me this arc right here is 90 degrees. Okay, find the length of segment PQ. What they want us to find is this segment right here, which we haven't had to do in this lesson. Okay, so let's make some sense out of this. Here's what they're trying to have us realize. If this is 90-degree angle, this central angle is a 90-degree angle, or in other words, this is a right angle. Okay, here's another thing. These lines going from the center to the outside, those are called radiuses, and all radiuses on a particular circle are the same length. If this is 7, this radius is 7. Okay, you might be starting to kind of recognize this triangle. It has two congruent sides. This is actually a special right triangle. All right, so that's the weird connection they want us to make, that this is a 45, 45, 90 triangle. All right, and if you guys remember, the rule is that when we're given the leg of a 45, 45, 90, first of all, the two legs are the same. Okay, we already got that. But the hypotenuse is the leg times the square root of 2. Okay, so that's actually your answer on this one. Okay, a weird problem thrown in special right triangles randomly, but it's a good thing to remember. Okay, keep moving along. These next are, asking us to, I guess, to think a little bit outside the box. Number 21 is asking us to find the measure of arc AC. So let me just highlight it. Okay, that's an arc that, goes from A to C. It's a minor arc, so it's this shortest distance between the two. Okay, so that's what we're asked to find. They give us some info. They tell me this is a 90-degree angle, and they also show me that these two arcs are congruent. Okay, that's important that these have these lines through them. They're the same measure. Okay, so here's kind of the idea. I know that if this is 90 degrees, that this arc is 90 degrees, right? And I can find the rest of the circle by subtracting that from 360, right? I can take 360, subtract 90, and if I do that, I'm going to get 270. Okay, so now what I just figured out is that these angles add up to 270 and they are congruent. Okay, so if I take that number and cut it in half, I'm going to get what each of those measures is, and it looks like it's going to be 135. Okay, and there it is. It's the measure of my arc. Okay, so remembering that the angles add to the arcs add to 360, all that stuff is an important part of this section and some other ones. Okay, so I'll let you try these out. These are kind of puzzly, but I think you can do them. Okay, so yeah, if you want to pause the video and try the front side, feel free. I'm going to move on to the back. All right, so the back side gets into inscribed angles. I'm going to leave number 1 to you. It's asking which of these statements is true, which angles can we say are congruent to one another. If you were here for the notes, that should be a really easy problem. Okay, take a look at number 2 though. Asking us to find arc ST. Let me highlight it. Just this little guy right there is what we're asked to find. All right, here's what they've given us. They've given us the measure of this inscribed angle. All right, if you guys remember, here's the rule. The measure of this inscribed angle and its intercepted arc, if you follow the side lengths, this is its intercepted arc. Okay, that angle is half the measure of this arc, or this arc is double the measure of this angle. So if I take 61 and multiply by 2, I get that this is 122 degrees. Okay, it's not what they asked for, but you can hopefully see where this is headed. Now that I know that this arc is 122, I'm looking for the rest of a semicircle, right? Here's my diameter. This whole thing is 180 degrees. All right, so yeah, I can take 180, subtract 122, and I've got my missing arc, which looks like it's going to be 58 degrees. Okay, and if you guys could put your answer, like you can put it on the circle, I like that, but also put it off to the side and maybe like put a box around it, like just to make it completely obvious when we look at this. Okay, so yeah, let's make our way down. Let's look at number 7. This one I thought was kind of interesting. This one is asking for arc VST. Okay, so let's first highlight that arc. Starts at V, goes through S, all the way to T. All right, here is kind of the, I guess, interesting thing. This VST is a minor arc, and they named it with 3 letters, which I think is kind of interesting. I mentioned before that minor arcs are normally named with just 2 letters. If they are named with 2 letters, yes, it is a minor arc, but you can name an arc with 3 letters and it still be minor arc. If that, I don't know, but I just want to point out that I thought that was kind of interesting, but this is what we're looking for. Okay, so what do we know? Well, we know that this part of our arc is 39, okay, which is kind of weird. And we know this arc, we know this inscribed angle. So this is a problem where just starting to find stuff is probably the best way to go. Here's what I know. Inscribed angle is 51. I know that I can find, let me change colors. I can find this intercepted arc by using the rule, right? The angle is half the arc is double the angle. This is going to be 102 degrees. Okay, well, look what I'm looking for, or at least part of what I'm looking for. I can now find ST by subtracting all of this from 360. Okay, so, sorry, let me see. So yeah, in my calculator, 360 minus 135 minus 102 minus 39. Okay, let's see what happens. Okay, I got 84. All right, just be careful. You might be tempted to think that's your answer, but that is not your answer. That is ST, and we want VST. All right. We want the whole thing. So now we need to add together this and this. 84 plus 39. This whole arc is going to be 123 degrees. Okay, so that one required a few things. I think that's a really good problem. If you have this all figured out, it's not difficult, but it requires a lot of what we've learned. Okay, cool. So I just got a couple more. Take a look at numbers 8 and 9. Right. This one is asking for a couple angles. The directions are important. It says find the measure of the indicated angle or arc, given that the measure of arc LM is 84. So they start to give me measures in the directions. So arc LM, let me highlight it. Here's arc LM. Okay, so that is 84. And arc KN is 116. Okay, that is, again, just named with 2 letters. So that is the shortest distance from K to N. They're talking about this arc being 116. Okay, cool. So let's dive in. Number 8, the measure of angle JKL. Okay, first of all, where is it? Well, that starts at J, goes around K to L. They're talking about this angle right here. All right. Here's what we have to, I guess, notice. This is an angle that's part of this inscribed triangle. All right. And if we realize that, here's the other thing we can notice. One of its side lengths is a diameter. And if we ever have an inscribed triangle with a side length that's a diameter, we know that it is a right triangle. This is a right angle. It is 90 degrees. Okay, there it is. Okay, so that's just using one of those theorems that we learned at the end of the lesson. Let's take a look at number 9. Measure of angle MKL. Okay, let's find it. That starts at M, goes through K, all the way to L. Let's see. Oh, this one's almost too obvious. I don't know if I want to do this one. Let me see if I can find a better one. Yeah. Actually, I'll leave it at that. I'm going to let you guys try this one out. I highlighted it. We have its intercepted arc. Let's see if you guys can find that angle right there. And then that can kind of lead you to some other problems. Okay, so I'm going to let you guys go ahead and try that one out. And then, yeah, let me know if you have any questions. I'll see you.